I think I recorded it. Yeah, okay. All right, okay, so you guys are particles. So you're gonna stand in a line between me and Marley. So kinda, okay, good.
Thank you.
All right, face the camera. All right, so now what we're gonna do is so our tennis balls are particles, okay? So we're gonna do a little review first. Show me if all of these particles were part of the same substance, what would it look like if we were a solid? Okay, good. All right, so people in the audience, does that look good?
Yes.
Yes? Okay, so we're noticing we're a solid because we are close together, we are touching, we're not going to show it, but we're very, very smally vibrating in place. We're just going to be like this though, and we're not moving past each other. We're just kind of literally frozen.
I
All
see a little bit of movement. No, I'm joking.
So now, okay,
You don't see a lot of it.
now would it look like if we were liquid?
Yeah.
So we're like spread apart, we're kind of moving past each other, right? Okay, we're moving past each other. Okay? So now, without us moving, our feet staying in the same place, what would it look like if we were gas? Okay, awesome. Now, solid. Gas. Solid. Gas. Solid. Okay, good. Excellent, excellent. All right. So now, that was a nice little particle diagram review. Now we're going to look at what happens when you add heat.
Wait, but what if you were a liquid?
We already did that one.
Oh yeah.
You missed it. All right. So now we're going to do, so I want you guys to be a solid. Show me a solid. So now I am going to be heat. So I have these hot hands, my magical hot hand gloves. So I am particles that are moving really, really fast. All right? Now if you're a solid, thank you. If you're a solid and I bump this, all right? What is the reaction?
Not that far.
So, you spread apart. Brendan, what happens?
You spread apart slightly and you start to move a little bit more.
Mark, moving a little bit more because what has happened? Where has the heat gone?
So, and it would start to turn to a liquid, right?
It would start to turn into a liquid, but the heat has gone to the entire solid, right? It is conducted all the way through the Spencer, like that, very, very quickly. Do you guys see that? Right? So solid one more time. So I bump Theo, and Spencer's bumped immediately. Conduction happens extremely quickly in solids, okay? Question?
I don't know have a question related to this, but like, say like a solid is like a piece of wood,
Uh-huh.
but that can't, if you like heat it up, it will like burst into fire, it won't like go to a liquid.
Okay, so, yes, that is a chemical reaction as opposed to like solid, liquid, gas phase change, okay? So it's similar to how if you have liquid pancake batter and you heat it up, it turns into a solid pancake. But that's a chemical change, it's not solid, liquid, gas. But, going back to what she said for wood, so the key thing about wood is that go into a solid. In wood,
I'm there, Spencer's fault.
Spencer, come back. In wood, the particles are a little bit further apart. So spread a little bit far apart. Good. So now if I hit Theo, it's going to hit everybody, but not as immediately. Okay? So that's why wood, styrofoam, down feathers are really good insulators.
Oh,
So now,
So it takes longer to do it, so it's like, so if you had a down coat, would it not keep you heat, like, is that why you'll eventually get colder when you're outside in like a down coat?
eventually, yes,
Yeah.
but not immediately, right? Because it takes a while for the heat to go out. Okay, so now show me liquid.
What if you put it back on? Then
Okay, hold that question for a second. All right, so we got liquid now. So now I hit Theo. She eventually hits Lily and Maggie and then Spencer, but it took longer, right? Do you guys see how it took longer? So liquids are worse at conducting. Now show me gas. Now I hit Theo. Does she hit anybody else? She maybe hits Maggie, but maybe that's it. Spencer isn't getting the energy at all. Right? Spencer's just still doing whatever Spencer's is doing. Okay? Alright. Now let's say, Maggie, put your stick down for a second. Lily, put your stick down for a second. Let's say this is a less dense gas. Now I hit Theo. Is it ever getting to Spencer? No. Okay, now you both Spencer and Theo put your sticks down. Now we're in a vacuum. I hit nothing. Does it ever get to Spencer?
No.
No, because there's no particles.
And so you wouldn't even be a particle, so you wouldn't even be able to hit something.
Exactly. I'm not even a particle. I don't even exist. I am just stuck. I'm stuck over here.
Yeah,
I'm a particle stuck over here. I'm not getting anywhere over there. I'm not getting to Marley, right? Because it's a vacuum. Okay, now, let's say we have, this is a free electron. Would anybody like to be a free electron?
Ooh.
Okay, Brandon Alexandra.
This is his time again.
Yes, this is, okay.
Don't they need to wash their hands?
Oh, yeah.
Oh,
Sanitize.
come on.
I just washed my hands because I went to the bathroom.
There we go. Okay. So, now you're free electrons.
Woohoo!
Now, let's pretend. So, if you zoom in to solids, there is actually a lot of space. Right here, right here. So if you zoom into solids, there's actually a lot of space between the actual particles. All right, if you zoom way, way, way in, okay? So let's have, you guys are going to be spread out. Just stick your stick straight out. Brendan, you're not doing anything right now. Hold on. Okay? So if I hit this one, let's do a chain reaction all the way down to Spencer. Okay? That takes a certain amount of time. Now let's say, so that's a normal non-metal solid. Now, in the same time, I'm going to hit Brendan's stick and Theo's stick at the same time. Brendan can run all the way down to Alexandra.
No, you can't hit people.
Right?
But-
Okay? So come down here, we'll do it at the same time.
Why? Like, this is aggressive. I'm
Okay?
Jesus.
So, here we go. Hitting both of you at the same time.
You're supposed to run.
You can run all the way down. Okay? So, basically what we're showing is, did that happen faster?
Yeah.
Right? That happened a lot faster. Why did it happen faster?
Because we were able to,
Because the free
we're very small,
Yeah.
we're a lot smaller, we can go between and bounce in between.
Yeah, because you can run around all of these atoms. So while Theo is bumping Maggie, who's bumping Lily, who's bumping Spencer, Brendan can just skip the whole process, run all the way down to the end, and hit Spencer. Basically teleporting.
Wait, what
It
about,
moves so fast, it's basically teleporting.
No,
what about like
it's really
not adding
gonna be
heat? What about
very
adding
straightforward.
like
Yeah.
freezing? Like
Okay, so freezing. So you can't add cold, all you can do is take away heat. So-
can you add something that's already been chilled? Like can you like
So if you add something that's really cold, okay, so
add
let's,
like liquid nitrogen? or
let me take my gloves off. So now I'm freezing, You guys, let's say you guys are gas, you're moving around. Okay? I am freezing, I'm not moving hardly at all. What's gonna happen to the energy if I come into contact? Who's gonna give who energy?
You're gonna
We're
give
gonna
them,
give
you're gonna give
you
you energy because it goes from hot to cold.
Yes,
Oh my god, Junior.
right?
Smart.
So you can't add cold, you take away heat. So now you guys are hot and I'm cold. Okay? Does that make sense, Maggie?
Yes.
Okay. Awesome. Put your sticks down, sanitize your hands.
Again.
Yes.
Oh, the red one moved down.
Oh.
Oh.
What does that mean?
Oh.